So we just completed a UNEP WMO integrated assessment report looking at the opportunities for reducing tropospheric ozone and black carbon to deal with this climate issue. And the report for policymakers has just been released. The report itself is still being printed. It's not, the full report is not out yet. But the good news is, by looking very specifically at source sectors, by taking into account the co-pollutants, by putting them through models and doing some cost estimates, there seem to be, identified in these are actual measures that offer winning opportunities. And the measures that are focused on BC are looking at things like high emitting sources. So this is a heavy duty truck that's clearly, and this is not even loaded, is super emitter. Substitution for clean fuels for cooking, banning agricultural waste burning, improved enforcement of regulations. So a lot of these, more specifically, looking at cook stoves, these high emitters, largely those are in the developing areas. In Europe, it's looking at even higher efficiency diesel particle traps, and also at the higher latitudes, looking at fire heating. Scandinavian countries do a lot of wood burning and replacing the traditional stoves and fireplaces with better designed fireplaces, because that turns out to be a large emission source. And at the higher latitudes, they have a larger impact on the Arctic region, which is one of the most susceptible regions. So by our analysis, by the team's analysis here, this is what the report offers, is opportunities. This is a busy slide, but let me just look here at the CO2 at the reference scenario. Okay, the reference scenario is looking at the A1B scenario for the future if CO2 is going to grow along those lines. What's plotted here is the continual growth of CO2 as the reference, and the temperature change of the global atmosphere. And this is, the relationship between these and the temperature response is still highly uncertain, but this is our best estimate. You can see the uncertainty range here is the height of the green bar. So we're on a path right now for perhaps leading to a 3-degree change of temperature. And up until very recently, and I think what the next IPCC report will talk about, I don't think they've actually determined, but the previous IPCC report talked about 2 degrees as our magic target. If we can stay below 2 degrees, there's a higher likelihood that we're going to avoid any serious and quick climate change disruptions. So 2 has been the target that people have been trying to find measures. Can we stabilize below 2-degree change of global temperature? There's some new research that's coming out that is arguing that 2 degrees is too much, that it needs to be worse, it needs to be kept less than that, but that's still an open discussion. So here's the reference scenario. If we just look at CO2 measures alone in this report, and we looked at it from a cost and technology, the ones that can actually be done over this time scale, you can see that CO2 measures alone still don't do it. They don't get us there in time. If we go out longer, if we go to the end of the century and early the next century, again, CO2 is going to have to do it for us. But when we looked at the methane and the black carbon measures, and largely black carbon is an important one early on, you can see that we take a much different path over the next couple of decades, that we're able to move with a much slower rise of temperature. And we get to the point where CO2 growth is again taking over any reduction that we're getting from the pollution side of it. But you can see we're on a much different path. But if we only did those, we buy time for several decades, which is critical, because hopefully we get smarter and technology gets better, that we can do these CO2 measures faster than we can project now. And then if you see that if we actually do those together, the methane, the BC, and the CO2 measures from this package of options together, you can see that there's an opportunity to stay below 2 degrees. And the really nice thing about these is that there's a lot of synergism between, many times BC measures and some of it is switching fuels, and some of those fuels will have a lower CO2 emission, and so there's win-win strategies within the measure. It's dealing both with the reduction of CO2 and with the reduction of black carbon because of the efficiency of being able to provide the energy or whatever the need of that is. And so this report then goes on to say, okay, this is the temperature side of the story. Then running those, the changes of pollution levels through the crop model and the human health models. You can see if we go to these measures of treating CO2 and the short-lived climate forcers as a combined strategy, you can see that we have even just the pollution levels has the largest impact on the avoided crop yield losses. Those are 50 million tons estimated. And from a human life perspective, also the short-lived the air pollution has the largest impact on the human health, avoiding 2 million excess premature deaths from that. So this UNEP report is optimistic within our understanding and with a large degree of uncertainty that there really are measures that are low-hanging. There's no technology limitation to implementing these right now. There's no need for breakthrough technologies. There are things that we can do. It's a question of putting in place the policy, the infrastructure, the financing that would allow those to happen. So let me just end then. So this report has taken and identified some opportunities. The question now, there's a lot of discussion and there's international interest in moving forward. At national levels, the US EPA is very interested. The international levels, the cooperation is really pretty exciting for doing this. And so we're working with Scripps Ramanathan on, he's designed an experiment where he wants to go out and document that we can implement some of these mitigation strategies at large scale, so at the village scale implementation, and the idea of trying to create a hole in this atmospheric ground cloud, so by this and actually documenting it. And here, the technologies being looked at are really, it's a tough one because the cook stoves are critical. A long history of improved cook stoves that haven't worked for a variety of reasons, haven't made a large penetration, and so, but if one can get in there, then that's the strategy that's been identified along with some biogas production. And just recently completed a very small pilot project looking at a few homes in the village. And this is indoor measurements of black carbon in this particular village house. And you can see for 3 hours a day, the black carbon concentrations are more than 100 micrograms, can reach more than 100 micrograms per cubic meter at all of the cooking times. These are huge exposures to black carbon. In polluted areas, you can see black carbon, 0.5 to 1 microgram per cubic meter is an indication you're in a polluted environment. These are very, very much higher than that, and because there's so many cook stoves, the outside environment is also highly polluted. So the idea is to go in with these interventions at the village scale of 10,000 to measure this village before the interventions. They have a large-scale interventions of penetration of cook stoves and other components, and then do our best to measure and document, and both using in-situ measurements, but also to look at the regional scale detection capabilities. So let me close with this. Again, hopefully you have a better understanding that there is this expanding global component of even air pollution, and that the management moving forward of air pollution really is going to require a larger view of what's happening in the northern hemisphere. And so this idea, that has implications. The idea is that that we can only worry about China, or also things that we were doing before with this globalization. You think of all the outsourcing of manufacturing where we were moving our dirty industries to China, because A, it's lower cost, and B, environmental costs to us are less stringent. But I like to say that's a little bit like being a Girl Scout and building your latrine, upstream of your campsite, because you can't go far enough in the northern hemisphere. It doesn't matter where it's coming out; it's adding to the background levels, and we have to manage this collectively at the background level. So that's one important component. But with that growing recognition has also come this recognition of the closer coupling between the air pollutants and their role in the climate system. And so now I have multiple ways I can approach the climate in the air pollutant system. If my air pollution is my number one problem and I'm going to have to do things in the future, I may be able to do things smarter, and I may get some benefits, or somebody may pay me to do something a little smarter if I also have a climate benefit. If I'm driven by climate policy, then the air quality opportunities then bring a whole other set of tools that I can use in the next couple of decades to really tackle the climate problem. So I think it really is an exciting time, and it's gotten a lot of attention, and people want to do things in this window of opportunity of dealing with the short-lived climate forcing is really a pretty hot topic right now. So I'll stop there. Thank you.